Now let's talk about some object-oriented JavaScript. Um, so this, as usual, I want to call it out specifically for new folks. This should be less me talking at you because y'all can read pretty well, and more just kind of me talking through some stuff and giving you the opportunity to stop me and ask questions either about the stuff I just said or about the stuff that you've been working on that uh, interfaces with the surface that I'm giving you to ask questions on. So before we jump into it, do y'all have any questions about any of the material or any of the labs or exercises you've been doing far, or anything about what you've done so far that you would like to talk about? All right, feeling good so far. Cool. So let's talk about some object-oriented JavaScript. Um, I know it touches on this a little bit in the curriculum or in Canvas, but I wanted to talk a little bit about it in general. Um, what we mean when we say object-oriented programming, why we do it, and all that good stuff. So, what is object-oriented programming? Basically, short version is uh, it focuses on what we call objects. Objects are chunks of data with ways to manipulate that data attached to them. Um, that's basically all it is. And those objects, can contain objects, so you get a nice little ecosystem there. Why do we want to do that? Because sometimes it is easier for us as developers to think about the things that we are working on as actual things. So if we have we're working with customer data, it's easier for us to think about, the customer object that represents that data and ways to manipulate it there. Um, the alternative is kind of what we did in phase one with the vanilla JavaScript. You can do that style of programming in pretty much any language, Python, Ruby, whatever you like. But instead of having chunks of data that had built-in ways of operating on it or methods, we had just kind of data hanging around. Sometimes we'd collect it in an object or some global or something that we can do stuff with it. But pretty much it was just data hanging out that we operated on using functions, or just code in general. Um, and so the one of the benefits of OOP is kind of less having just data hanging around, not really organized, just having things hit it at random, basically. And you can definitely get sloppy with objects for sure. You can also definitely get way too structured and picky with objects. See Java. Um, yeah, um, but it's a tool. There are very few object-oriented programming languages. Like Smalltalk is one of them. Um, I forget what a more modern was. They're very few and far between, where literally everything is the object, and the only thing you can do is operate on objects. That is nice in theory, but it tends to get cumbersome in practice. So most languages you're going to use, like JavaScript, like Python, like Ruby, like C Sharp, like anything, is going to be some combination of techniques. Python is an imperative language, just like JavaScript, just like Perl, just like anything else. It has a script. You run stuff from the top down. Sometimes you organize those things into objects, just like any other language that has objects. Um, Languages like Python, Ruby, they make sure everything that you interact with is an object. So bare numbers are objects as opposed to in JavaScript where they are just primitives. They're just things you have to operate on. So that's nice. But it is one way you can, you know, you can write Ruby code, which is the most object-oriented language that we would talk about here. You can write that procedurally as well. It also, languages that have a combination of that and object orientation and functional programming. JavaScript has all the map, filter, sort, um, the other one, reduce, and you can basically, these are tools. They are not rules. Just because things object-oriented stuff is available to you does not mean that everything has to be an object, unless you're in a language that doesn't allow you to have other things. So that's kind of what it is and why we use it. There's also a nice kind of philosophical best practices, design patterns. When we talk about objects, there's the kind of original design language book called Design Patterns by the Gang of Four. It's four developers who worked in Java, I think, kind of outlining a lot of design patterns are just like recipes or best practices. They're just common ways to do something that we created a simple word for so that we can talk about it without describing the whole thing. So like a singleton, where we have a class that can, with instances all refer to the same thing. We have words for this, a factory, something that creates other stuff. So that stuff is not anywhere near our curriculum. It is really interesting, I think, and a good exercise in pulling useful things out of a larger text that may only be useful to a certain audience, but definitely worth looking at. A lot of object-oriented talk, and I, again, don't think we talk about this specifically in our curriculum. There's kind of and this comes from way back, the sort of four pillars of object-oriented programming. And these are basically four of the big things that object-oriented stuff provides you, or should provide you at least. Can I remember all four? Abstraction, and that means, instead of that's basically the fundamental of it. We are taking some stuff and saying this is a thing instead of this is some code. So we're kind of like abstracting the thing we're talking about into a quote unquote concrete object. Encapsulation, and that is, you'll see that in regular procedural or functional programming, where we take stuff and encapsulate it in these objects or functions or whatever. One of the core things about encapsulation that Python and a couple other languages don't really address is basically we want that interface. We want an object with methods, and we don't care, and we should not be able to look at or change how they work from the quote unquote user standpoint, which means defining private variables and private methods and stuff. Python doesn't really do that well, but you can pretend, basically. So there's abstraction, encapsulation, inheritance, which means that you can define objects like you have an animal object. So all animals are abstracted into this class, and then you're going to have things that inherit from it, dogs, horses, giraffes. And so you can define a bunch of things about an animal, and then when you have something that inherits from it, those things get all that stuff and all the ways to act on that stuff automatically. So you can have animals have a lifespan and a heart rate and a height and a name, or whatever. And when you have other specific things inherit off of that, they automatically get those things, but then you can add stuff to them to make them more specific. So a dog might have a a fetch method. It might have I don't know, a chip ID or something. So that inheritance lets you create more abstract classes down into more specific classes, and so on and so on and so on. There are some ontological issues with that, which I won't talk about because they're way beyond the scope of anything we're going to think about. But kind of leads us into the fourth one, which is kind of the hardest to get your head around, polymorphism. And basically that means that when you inherit from a parent class, you can have methods that do different things for different kinds of things. So we have an animal class, and that animal class has a speak method. And by default, maybe it's not implemented at all. Maybe it's an abstract method, but everything that inherits it implements it differently. So when you have a dog that inherits from animal and you say dog dot speak, it will say woof. If you have cat dot speak, it will say meow, and so on. So polymorphism is the idea that you can have different subclasses of a thing use the same method to do different things depending on what class they are. And I don't know that that comes up a lot in the stuff that we do, but it's an important part of object orientation. And again, there are a billion other things. Those are like the four things that say, like, if you are an object-oriented language, this is basically what you have to do. Yeah, cool. So that's the philosophy part. That's the sort of meta stuff. Any questions or thoughts about any of that? Didn't think so. Yeah, I'm happy to talk about any of that at length, clearly. So let's talk about how we do it then. I'm going to share screen and we will look at some code. In fact, I think I can just share the code because we're only using that. Cool. Let me bring up chat up here. Chat just in case. Put y'all over here. Awesome. So I'm going to walk through some examples and whatnot here as we go through each piece. So the fundamental thing in OOP is creating classes, right? So we're going to be, and actually, let me give you a little preview spoiler about what we're going to be using, why we're hammering on this so hard in this instead of in JavaScript, which also is fully object oriented as well, except for the primitives part, or most other modern languages have some of this. Why are we harping on it now instead of before? Two reasons. React used to be primarily object oriented, and they in the last few years changed to be more functional instead of object oriented, just to make it a little bit cleaner to look at. Yeah, so we used to talk about objects before in JavaScript, but we didn't. So now we're talking about it in Python. Why? Because we want to use that abstraction to say, hey, I have a playlist object. That playlist object contains not children, but it is composed of song objects, say. We would like to operate on those objects to, read, write, update, remove things from them, or whatever else you want to do. And when we do that, we would like those to be reflected in our database, whether that is a relational database or a JSON DB or a text file or a guy named Maurice that you fax things back and forth to, whatever the storage mechanism is, we don't want to care about it when we're programming. And abstractions are all leaky to some extent. So there's never a perfect abstraction. Ruby does a really great job of it, but we want to be able to operate on those things without having to worry about how that data is stored in our quote unquote database, whatever that is. So that's why we're hammering on object-oriented stuff so much here, is because we're going to use objects to abstract our data, and then we're going to have those objects hooked up to a database in a couple weeks. And so that we can operate on these objects and not worry about too much of being stored. So right now we're just going to work on the object part and worry about the database part later once we get better at this. So all that being said, let's make some stuff. Pet is like, for some reason, animals and pets are the kind of standard demo thing, which is, I would prefer that it was a real thing, but pets are real. That's great. So it is, for everything it has, Python does a really good job of making this syntax pretty painless at the beginning. So how do we create a pet class? It is, as you would expect, we want to just say class. So we use the word class. That is a Python keyword that the next thing we type will be the name of our class. And so I'm just going to say class pet. And it uses kind of the same syntax with the colon and the indentation and stuff as functions and whatnot do, other blocks. Right now, we're not doing anything with it, so we can just say pass. And pass is just a, since Python doesn't use visual indicators for blocks, we can't just like make an empty function, or class. So we need to put at least one line in there that doesn't anything. Pass is just a no op, it just doesn't do anything. Cool, we have made a pet object. Congratulations, us. Yeah, and like everything else is going to be built off of this. So the again, one of the fundamental things that can be hard for some people to get their heads around is the distinction between a class and an object or an instance of that class. Class is kind of like a template. So when you create a new pet, you stamp out a new one of these things and you get a freshly minted pet. The pet object or instance is not the class. It is a thing that class defines, but it's going to be its own separate thing. So let's make some pets here. Let's let's go ahead and make some cats and dogs. Let's say we're gonna say I don't know, this is a and how do we make a new pet? New pet, is that right? It's just gonna be pet. And we would, if we we're adding stuff, put some stuff there. We'll talk about that in just a moment. Garfield, pet. Every language is different, clearly, uses different syntax. My brain is still primarily JavaScript, so I'm going to make JavaScript class mistakes when I'm typing this, because I don't use Python on real projects day to day. So I will make mistakes here. In JavaScript, it would be new the thing, and a lot of languages do that too. So we can we can look at this. Let's make sure that it's not going to blow up here. I'll talk about that later. I'm just going to say Python py because I have nothing. Great. I'm actually going to make this. So we have the hash bang up here, and basically this is just a pseudo comment that says what we are going to be running this with. If we look at it now, this pet py is just readable and writable to me, but it's not executable. And I can chmod, so change the mode of it. I'm going to say plus x for pet.py. And so now if I look at it, we've got X's all over the place. Now is a program that is executable. And so instead of saying Python pet.py, which we can still do, I can just say pet.py and command not found. Awesome. Doesn't need a space there, right? There we go. I don't know why that space was there. Cool. So now it is looking at the first line here and saying, oh, it's going to be Python, and it's going to run it as a Python program. So right now we don't have it doing anything externally. We can. So if I'm remembering correctly, and I think I am, since everything in Python is an object, classes are also objects. So I can print the pet class, and it will show us, hey, it's a class. And it's in our main namespace called pet. Cool. So not only do we know that it's a class, but we know what class it is. And we can do the same thing with our instances. And so now we can see the difference between these things. This is our class itself. This is an object of that class. And we get a bunch of gobbledygook numbers here. That is the address in memory where that lives, more or less. And this kind of exposes something that you will see sometimes in JavaScript when you're looking at objects, but like objects and lists or arrays in JavaScript, these are reference types. These are the addresses of what they are. So the contents are not this thing. So since these are two different pet objects, they're going to be two different locations, values here. So even though right now they point at basically the same kind of thing, they are different. Yeah, that's just a thing to note, I think. Let's see, what do we have here? They are not the same. Yeah, they're not the same, but created from the same mold. Cool. So I have next up how to implement a simple class. Let's write. Yeah, I guess let's do that first. So when we make a class, we don't want it just to be an empty thing, clearly, or else we wouldn't make one at all. We want to have it set up certain things when it initializes. So in this case, we're going to add some, and this is the data part of our object, right? This is going to be things that live on the object. And we can add that when we create a new object. When we're creating an object, it's going to run a special function. That function is called under init under, which makes it difficult to type in Markdown, but we get by. So I'm going to move this down here. I'm going to get rid of these prints too. Get rid of these Paul prints. Let me just comment these out for now. I'm going to retype it down here. So let's make our class pet. So what do we want to do? First off, we want to initialize our class. Or when we make a new instance of a class, we want to initialize that object that we are creating, sending out to the world. So to do that, we're just going to write a function, and we're going to be half the things we're going to be running in here are functions, or maybe the majority of things, I think. Functions that are attached to an object are called methods. They're still functions. If you call them functions, it's fine. But that kind of function is called a method in modern terminology. So if you're wondering about what the difference is between a function and a method, that's pretty much it. So let's print, let's set up, hey, we have it right here, initialize. We're not take anything there, and we're not going to do any of that there. So this is the init method. It's going to run anytime we make a new instance of the class. And we can see that by doing print new animal coming through. So when we make a new one, and we get back down to the root level, if we get our buddies down here, when we run this, we get an error because 0 positional arguments, but one was given. Right, self. Great. Most methods in Python need to take self as an argument, and we'll talk about that in just a moment. Yeah. So we can see here when we create these two things, it is calling that function each time we do it. So this is where we want to put a bunch of things to set up our animals. So we have some suggestions here. I'm probably going to do fewer of those because that would be less typing. So self here, what is self? Self is a special variable that gets set up by the initializer when, well, it's a special variable that gets set up by the class setup that refers to the instance of the class when used in a function like this. So when we say self in init, what we are referring to is the pet object, like Service or Garfield or whatever. And so we can then do things to the object in here using that. So if I want to use a name, I can say self.name, and we're just using standard old dot notation, just like we're familiar with here. We're going to say self.name equals what? We want to give it a name. And to do that, we are going to give it an argument here. And so self, we are never going to pass in self here. Self is automatically passed in by the class. So let's say name. And so we're going to say self.name equals name. Great. So now we can make a, well, let me do a couple other ones. Self.species. Put that up there. And we'll do age. And now when we look at these, let's make sure there's no errors there. 3, great. Yeah, there's errors because we didn't pass in the things it's requiring. So let's pass in those things that it requires. I'm going to call this one, give it that what it is. Give it a species, dog, and age 5,000. We're going to give Garfield cat, and Garfield's probably like 40 years old, right? Cool. So now when we run this, we should not get errors. We're passing in all the arguments it requires. And now we can see that printing that name. So when we instantiate those with the things that we put in, those are attached to that object now. So we can start pulling stuff out of there. The way it's set up now, we can also change them by default here. So if we say Cerebus species equals hellhound, and let's look at it here. Easy there. So we're going to print out the species before we change it. We're going to change it. We're going to print out after we change it. It does what you expect. This breaks the encapsulation part. This kind of behaves just like a standard like object that we're familiar with from JavaScript or in here, dictionary. this is really nice for flexibility, but it is not nice for encapsulation. We don't want people using our class to change things without going through some sort of interface that we've defined, or maybe we do, but in the standard object-oriented stuff, we generally don't. And we'll talk about how to get around that in a little bit. Most object-oriented languages have the concept of a private variable, and that's defined in different ways. We might say, it might have a private keyword, might have a section that everything after it is private, it might have a different notation for it. Python, we don't do that here. There's no such thing as a private anything inside of a class or an instance. So that is all by convention and people being polite with each other's code, which leads to a certain amount of not doing that. But you get what you get. Cool. This is the super basic stuff. Any questions so far? Cool. So we did that. Great. Right on track. So we can also, so we have things that are defined, these properties. So we can also define as per the definition of what we're doing, methods, instance methods. So there's instance methods and there's class methods. We'll talk about class methods soon. Instance methods are the ones that we're usually talking about when we say method. They're the function that's attached to an instance of the class. So all of these methods are going to be defined basically the same way that the init method is, even though init is quote unquote private, which it is not. It's just another method that we can use. So I'm going to, well, let's just see what, let's just print out our self here. And all methods are going to take self as a first argument. I'm just going to have a print out self. And so this, when we do that, we can say Cerebus, let's do this. Let's print it out there. And now we can do Cerebus self. And I would call that print self or something like that. And Python uses underscores most of the time instead of camel case. So if we say Cerebus print self, we should get the same thing off of both of those. Yeah. So again, the self that's printing is the object itself. And so we can see that it is printing the same thing in both places. Great. That's not very useful. So let's do something a little bit more useful. Instead of printing self, let's print the print details. I know there's someplace I'm pretty sure there's someplace in the curriculum that will do something like, oh, have it say print pet details. Anyone know which of the 4 pillars that kind of naming breaks? I don't expect anyone to know, but bonus points if you do. This is breaking our polymorphism. So ideally, we would be able to subclass this pet, right, into dog, cat, horse, sheep. And we already know that these are pets. We already know this is a pet. And so it might feel strange to have print pet details on the animal subclasses. Print details is better. We know it's a pet. We know these are pets. So we don't need to say print pet details. That is, and I see this a lot in tutorials and how-tos and curriculum, clearly, from people who are coming from more procedural oriented languages, where you just have data hanging around and you have to write functions that say what they do. And so if you have some data hanging around that is probably some pet data, you have an object like a JavaScript object or an array that has stuff in it, and we know that's a pet. If we just put that into a function, we need to say what that function does. We need to say that's, I mean, it'll work with whatever you call it for the user, the programmer. We're going to call it print pet details because that blob of data doesn't have any idea of what it is. But in this case, we know we're defining it as a pet. It knows it's a pet. If I look at it, it knows it's a pet object. So, and we're going to subclass it, and the subclasses are not going to be called pet. So, and this might be subclass from an animal class, which might be, subclass from a thing class. I don't know. So we want to make these as descriptive as they need to be, but no more. So super picky semantic point, but getting into these habits is going to save you tears and pain for the rest of your career. Yeah, I wish I had learned it earlier. Saved me a lot of time. Cool. So we are going to print the details of this object. And I'm gonna, let's print out, let's do a formatted string here. Is it a dollar sign? I forget. We're gonna say the name and do that self name. It's giving me guys. No, give me enough. Great.
No dollar sign.
There's no dollar sign, just that.
Just the curlies.
That's the curlies. I know. I've always wanted to do a pound sign, and that's Ruby, not Python. That's the problem with knowing more than one language. It's hard to remember which things go where. Cool. So we'll do self name is a, we'll say self species. I'll put it all here. Self age, year old. Great. Period, because this is a sentence. So now we can do things like Cerebus print details. And since we're not passing in, we don't need to pass anything into this. It's just a function. The class, basically the setup, it automatically passes itself. So we don't need to worry about that. I'll do the same thing for Garfield here. And let's see if I know how to do this. Hey, I do. Cool. So this is doing something nominally useful. We are using the data in this instance of the pet class to do something specific to that instance. Great. Clearly, we can do way more things than just print stuff out, but this is a good start. Oh, hey, look, I just did that. Great, cool. Thoughts or questions here? Get rid of all this here.
I'm still a little bit confused on like the detail naming for like the print details, print pet details. How would we know whether or not, like we've made something too detailed or not? Is it just something like through like experience would see?
Yeah. And again, this is a rule 2 thing. So whatever makes the most sense for you, new folks. My 3 rules of programming are make it work, make sure you can understand it, and lastly, make it efficient. So yeah, this is a rule 2 situation where our intention in naming things is making it easier for us to understand what we're doing here and making it easier for us to change it or debug it later on. So, if it is print pet details, it's fine. There's nothing wrong with it. You can, you say details. We don't know if that details is being printed out or returned or what, but for something of this size, it's good. We can even say, I don't even know what this is going to be. So it's just going to be a test. I'm going to figure it out later. The beauty of the medium in which we work is that later on, when we do we have a class dog, pass. When we have a class dog that inherits from this, we can say, oh, okay, instead of print pet details, it's not just a pet, it's a dog. So do I want a print dog details down here? That seems like a little bit much. So maybe I can look at what I'm calling it. Oh yeah, it's inheriting from that. So it's going to be using the same thing. So I can, it makes sense to just call this print detail, and then it's going to print the details of whatever this happens to be. And if you want to call it print pet detail and dogs are pets, that works too, if that makes sense to you. There's like pretty much everything in programming, there's not really a right or wrong way to do it, just a easier or harder way. You can call all your methods ABC, they'll still work just fine. It just, if you're the only one working on this, do what makes sense for you. If you're working on a team or with a partner, do what makes sense for everyone involved. That's pretty much it. Does that kind of answer what you're asking?
Yeah, got it. Thank you.
Yeah. Yeah, my overall philosophy is do what works first, and then as you come across things that make you think about it, never be afraid to go back and change your code. Especially just the names of things. You see me change the names of things half a dozen times in the course of half an hour, just because I'm like, picky. But it really does help in the long term. It feels weird and picky when you're doing it sometimes. So cool. Other thoughts, questions? Awesome. Let's see what we got here. Yeah, let's do that. Cool. So classes do not live in isolation. They often interface with other classes. Yeah, let's do this. So and again, this can be tricky for people new to OOP to understand. There is a strong temptation to conflate, to think about inheritance and composition as similar things. They're not. Inheritance, again, is creating a new class that is a child of the parent class, which has a lot of the same attributes and methods, but it's just more specific. Composition, which I don't know if we talk about specifically, maybe we do. Composition is basically having a class that contains instances of other classes. So playlist and song are two completely different, unrelated classes, but a playlist is going to contain probably a list of songs. In this case, we're going to create an owner class. An owner is going to own a pet. It's going to be related to this pet in some way, but they are two completely different things, except in the case of Goofy and Pluto, I guess. But in general, owners and pets are going to be completely different things altogether. I guess Goofy is not a pet technically, so although they would both inherit from animal. So anyway, let's create an owner class with these methods here. Let's see what this looks like. So we're going to create an owner class here. So class owner. Couldn't be simpler. Much simpler. So let's just follow some instructions here. We want to make a couple methods here. We're going to have an init method, so I'm just going to stub that out right now. Two of those. We're also going to have a def get name method, which is going to take in self and return something. We're going to have a set name, which is going to take self. It's also going to need to take another thing, right? Because we're going to be setting it to something. Ensure that owner's name is a string. If not, picky. Yeah, I guess we can do that. Cool. So how do we do this? We set names, set owners name. We're not going to relate them yet. Yeah, we got 10 minutes. Do we want to? Yeah, we'll see when we get there. So let's just create an owner class now. We'll think about using it later on, maybe tomorrow. So our init here is going to looks like the owner has a name, so it's also going to take in a name. And here we're just going to set the name to the name. Great. Yeah. So we can clearly set things by just the dot properties like we were doing before. We can set the new name by saying instance dot name. There are reasons that we don't want to do that. We will often see, well, I guess right here, this is a good example, which is why we're doing it. We're going to want to do other things instead of just setting or getting the value. In this case, we want to make sure that the owner's name is a string. Cool. So we're going to set it here. And let's just do a quick little example here. Object properties, attributes. Not my notes. So let's do a new owner who owns, I guess, equals new owner. Hey. Not new, not that language. Cool. So now this has a, we can print out Hades, and we can print out the name. So we are directly accessing that property there. When we run it, we get an error. Service print details has no print details. That's right. That's right. Great. So we can see down here. Bump that up without bumping everything up. No. We see down here. Here's our object. Here's a name, just like we did before. Easy peasy. But it's considered bad practice to do that in an object-oriented context. Python dictionaries, JavaScript lowercase objects are really great for storing arbitrary key value things. It's a not weird, but it's a subtle distinction sometimes between key value properties on a map or an object or a dictionary, and properties on a like OOP object. In general, properties on an OOP object should not be accessed like this, regardless of what language you're using. In general, we want to use getters and setters, and that's for a couple reasons. One reason is that we might want to do something else while we're getting and setting it. Maybe we have first name and last name in there, and when we get the name, it's going to automatically put them together. If we're setting something, we want to do some balance checking on what we're setting. We might, we will often use like an underscore to do that, and then when we and this is kind of like the convention, like, oh, if it has an underscore in front of it, it's private, and don't look at it. You can still look at it. But this lets us, when we look at it now, it's not going to give us the name itself. It's going to say we don't have one of those things. So we would write a getter like this, and all it's going to do right now is going to return self underscore name. And so when we call that as a method, has no attribute name because it's get name. Get name. There we go. We don't need that anymore. So now we are calling the getter method get name. And it is a method, so you do need to call it with parentheses. And again, the second reason for that is, this is a simple example, but we might change the representation of this underneath. Say we have our playlists, and when we start making our playlist, it's a list of songs, and we have a method that's playlist, and it gets the playlists it gets the songs back up. Has the method songs, it returns the list of songs there. Later on, for performance reasons or whatever, we might change the internal representation to a dictionary, so we can do quick lookups on stuff. But we still want to be able to return the list of songs with our getter method. If we were just accessing it directly, we would get a dictionary instead of a list, and then the people who are using it have to change everything. And if you're writing an object that other people use, that is a bad time for everyone. So, and that's where that encapsulation comes. When we get the value of a property, we shouldn't care how it is stored internally. For all we care, the name could be stored as a list of letters that's put together for some reason. We don't care about that. All we care about is when we get the name, we're going to get the name. Whatever the verb is, whether it's called name, underscore name, sandwich, dolphin, doesn't matter. We just want to get the name no matter what it looks like inside the class. That's not our business. As consumers of the class, we just care about what methods are provided to us. We don't care about how they're implemented. So stuff like this helps a little bit there. So I'm going to just do the same thing here with set name. It's not going to return the name. We're just going to say self underscore name, NAME. Try again, NAME equals name. Great. And so now, again, this is the first reason we're talking about. We want to make sure that the name is a string. And if we were just setting it directly, we couldn't do that. So we want to make sure this is a string. So do I want to do the age thing? Yeah, I don't know. There's a couple ways to do this. I'm going to just check if the type. So if I say, we want to do if, don't we? If, we need to do this. If type name, if the type of name is a double equals, not triple, is stir. So stir is a type that is the string type. So if that type is a string, then we're going to set it to self name. Else, ELSE. We're going to issue that warning. We're going to print this. Name must be a string with parentheses around it. Great. And so let's make sure the thing that we had before works. Always, when you're refactoring or adding stuff, make sure the stuff you had before didn't break by the things that you were doing. Great. All that looks good. I'm just going to do a print between here so we get a space. Great. So let's play with this a little bit. We've gotten the name. Great. If we, and we can't do Hades name equals whatever, because that doesn't exist anymore, and that's not the interface provided to us. But we can do set name, and that's going to be hey, Lord of the Otherworld. Great. And so now if we print the name again, we should expect to see the name with a full pompous title. There we go. Great. But if we decide to set it to a number, it should not do that. It should print out that warning and then print out the old name. Hey, look at that. That worked. So now we can see this is where we're going to be doing type checking. And, is it, is it long enough? Is the password long enough? Does it contain this other things? Is the name too short? Never do that. That's a terrible idea. but whatever restrictions you have on the thing that you're setting, this is where you would do that. And similarly for the getter, this is where you'd like, if for some wacky reason we're storing our name as a list of strings or a list of letters, this is where we would join those together into a string and return that. So doing it like this provides us two things. Again, it provides us ways to interact with the data before setting it or returning it, and it lets us encapsulate that data better so that it's not directly accessed and changed. Because if we do, this, name must be a string. Great, we can't, we can set the name. That's going to work fine there. If because this is Python and Python doesn't do privates, we can get sassy and do, oh, I know because I looked at the library, it's called name internally. So then I can set it to a number, and we don't need, we don't do semicolons here. So, hey, look, I just changed the name to a number, even though it's supposed to be a string. This is why you don't access properties directly, because something else, some other method, some other thing might be counting on that being a string, might be doing string operations on it. And when it hits a number, we're going to get errors. So that's why not having private methods and properties is not great, because someone's going to do that and they're going to complain. So that is that. Any what thoughts / questions do we have about all this? All right. So we're at an hour, but I'm going to do one little trick, I think, before we go. And you've probably already done this, so I'm going to do it real quick. This is kind of pain. Using them as methods like that. We need to do it for setters, but because we're setting a thing. But this feels clunky and not super object oriented. Some languages automatically handle this part for you, but we need to do it by hand here. So there's a thing in Python which are called decorators. Decorators are very cool. And later on, if we have time, I think we do have time, I'll probably next week talk about how to write your own decorators, because it's super cool. But there are a bunch of decorators provided with Python. Decorator is basically just, decorator is literally just a function that takes another function as an argument and does some stuff to it. In our case, we're going to use a decorator called property. And we can say property. And so what this decorator does, it says, hey, the next method that you define here, we're going to wrap that in some Python magic. And instead of having to call this as a method, we're going to be able to just say get name. So basically, I'm going to make a pseudo property here that we can use. And so, and it's still, well, we'll talk about the second part there. Hey, look, that totally works. So that's the simpler version. We can also do property here. Property. But we need to, oh, look, we have different kinds here. We can do a setter. And what that does is the same thing, only it lets us do this kind of thing and make sure it's in the same interface. So that should, yeah, that's great. Setter property doesn't apply to a function object. What am I doing wrong here? That should work. Oh, no, that's not right. I need to call the class, right? No, the method. Get name. I think that'll work. I think it's slightly different in the, nope. String is not callable. What did I do wrong? there's a different way to do this. What is it? What is it? Let me look something up. What am I doing wrong here? Oh, they're gonna call them the same things. That's right. Yeah. So I'm gonna call this name. I'm gonna call this name. And I'm gonna call that name. I think that's gonna work. Nope. Owner has no property. Get name. Get name. Name. Get name. Oh yeah, because I'm not calling the same thing. Hades name. Hades name. And this lets you. This is just a little bit of syntax niceness. This lets you set things without explicitly calling the functions get or set. Am I lying? Let's find out. Yes, I am. String object is not callable. What did I do? What did I do? Type error, string object not callable. I'm not calling it. Maybe it's doing something weird in there. Let me just take that type checking out. We can debug that later. Is that gonna work? No, it's not. No, what did I do? Why is my setter not working? Oh, hey, use property. Look at that. What did I do wrong here? Is it property setter? I don't think so. No. Property. Let me look this up again and see if I can figure out what I did wrong. I have to relearn this once every 15 weeks. Yep, that's right. Yep, that's right. That part right. The decorator. That seems like it should work the way I have it here. What am I doing wrong? Self-value. Am I doing it wrong down here? That's the question. String object is not callable. Let's look at the error. Line 46. That's helpful. Cool. 44. There we go. Oh, so I'm not calling the right thing. His name. Did I undo that? No. Okay. Same thing. String object is not callable. I don't think I'm calling it anywhere. What did I do wrong here? Property again. That is right. Why is it not working? Let's see here. Property that. Am I using old Python? Is this how it used to work and now it doesn't work anymore? Let me take a look here. One of the fun things about Python is that there are two different incompatible versions. I don't think this is that though. I think I'm just doing it wrong. Let's see here. Methods. Yeah, we're doing that right. Did that. That's right. If anyone sees what I've done wrong, feel free to holler. No, that's right. What did I do wrong? I don't know. I don't know.
Could you be using that built-in attribute function like the attr parentheses instead of dot notation?
Say that again.
On like use there's a build. I'm looking at this lesson that I was working on before, but it's a built-in function attribute attr parentheses instead of dot notation. Like
which lesson are you looking at here?
I'm looking at it's called attributes and properties.
Oh, look at that.
Uh,
Attributes and properties.
and it's a very similar kind of deliverables for this one where you're
Oh
making a
yeah, yeah.
list of dogs and breeds, and then the name has to be a string between 1 and 25 characters.
Mm-hmm. Yeah, I think I'm
Um,
using old or different syntax that I don't know how to use. That's really, really interesting. Um, well, that used to work. Let's do it the way that actually works then and not worry about what it used to work. So yeah, let's get rid of that. Let's get rid of that. And we're gonna say set name or get name again and set name again. And then we'll use that property method there. Um, man, I don't know why that didn't work. Get name and set name. Yes, set name. Cool. That should do the same thing. I'm real curious why the decorators didn't work though. Nope, same thing. Owner object has no attribute name.
I think you have to do name equals
Name.
property,
There we go. Maybe that's what I was doing before wrong.
or I'm well, maybe that'll work. But I meant up on 38, name equals property, then all that stuff.
Yeah, yeah. Name equals that. Hey, let's go. Cool. I bet this is what I was doing wrong before too. Cool. So woo, that's a fun trip to learn how to do a simple thing. Yeah, that is this is one way to do it for sure. So we do our getters and setters. These don't go away. We can still use these, I think. If we say Hades get name, that those should still work. It does, but this just makes it a little nicer to read. It doesn't really provide any protection, but it makes it behave more like what we do our modern sensibilities, what an object should behave like. I'm going to play with that other syntax. I'm pretty sure I was doing it right. I just did something wrong. I think this is where we're going to stop for today. Yeah, this feels like a good breaking point. Any questions about any of this stuff while I'm testing out my old way? Hey, that way works too. Great. Yeah, it was equals instead of function. Cool. So both of those ways totally work. Matter of preference, really. So yeah, thoughts about all this stuff up to getters and setters. No thoughts. We are empty. Great.
Yeah. No, makes sense. I'm excited to see, I don't know, like some more real, like the labs all make sense. They're not haven't been too difficult. But yeah, I'm just curious on like a real, more real world
Yeah.
examples. And I'm sure we'll get there once we, start putting everything together at the end of the week.
Yeah. Yeah, I wish we used more real examples for starters, but this is like the curse of every programming tutorial ever. So we will definitely see how to yeah, we'll see how to hook that stuff up in a better way. Probably maybe tomorrow, maybe Monday. We'll see. Yeah, that'll definitely happen, and especially that will happen on the code challenge next week. Awesome. Any other thoughts or questions here before I shut up? I'll tell you what, I'll turn off recording and then we can do stand down right now because no reason to just wait 15 minutes. So yeah, anything before we stop the recording? Going once. Sweet. Thanks anyone who's watching on the internet, and